Okay, before today's speech, let me tell you a little bit about our company's background. Our company is established in 1985. Cybernetics Systems has been providing CAE solutions and IT solutions through product sales, contract analysis, consulting, and software development for over 30 years now. We have developed a partnership with more than 20 companies, mainly in the United States, including Ansys and Synopsys and many more. Our head office is in Tokyo, and our CEO is Leiko Yasusa. The sales subsidiaries of Cybernet Systems consist of Cybernet China, Cybernet Taiwan, and the Cyphone, which is based in Korea, and of course, Cybernet Systems Malaysia. Cybernet Systems Malaysia is in Kuala Lumpur. Up until this day, Cybernet has been creating a network all around the globe. Cybernet is working with overseas group companies to develop software that will serve customers not only in Japan, but also around the world, and also to develop our group products and solutions overseas. Cybernet Systems Malaysia was established in November 2018 as the first subsidiary in Asia after China, Taiwan, and Korea. Our managing director here in Malaysia is Lokazu Zneki-san. Here in Cybernet Systems Malaysia, we currently have 5 employees, which consist of the management, administration, sales, and also technical department. Our business mainly is about CAE solutions, IoT, big data solution, and also professional services. As you all know, Cybernet Systems provides all sorts of solutions that can fit most of the customer's needs. Those solutions are including CAE solutions, AR/VR solutions, big data solutions, and IoT, digital twin AI services, IT solutions, and the last, engineer services. So that's all about our company's introduction. And let's welcome our speaker, Nicholas, to give us a speech about wireless and our introduction.
Hello everyone, I'm Nicholas Chang, the high frequency application engineer from Cybernet. Today we are talking about the Ansys wireless and radio frequency introduction. Talking about wireless and radio frequency, there are many people thinking about the antenna and RF circuit, even the RFIC. In fact, the wireless system, including the antenna and radio frequency circuit and RFIC, even the power IC and the module and the housing. So if we want to knowing about the wireless systems, you should go through some multi-physics simulation to know the phenomena of those physical. But there are some questions about does we can using the software to simulation about those physical phenomena. In this topic, we will propose some solution about the antenna array, and the radio frequency circuit, even the radio frequency systems. We all know the multi-physics phenomena is very important in the communication now. So let's go get. This is the agenda of this speech. I will introduction at first. The introduction will talking about what's new in wireless systems and radio frequency. Maybe I will focus on the multifaces by Ansys. The Ansys is a powerful software to solve the multifaces problem. So next, I will introduce the Ansys electronics product of the wireless and the radio frequency. Radio frequency, we often say is RF because that will be short than will to speak. First, in electronics product is the enterprise. The enterprise will including all electronics product of Ansys. Next is HFSS Premier. The HFSS Premier is a new package in the 2020. We will focus on the HFSS electronics product is many type and many companies. So we are focused on software today. The other software we will speak on the other days. Next, I will introduction the HFSS. The HFSS all the server and the HFSS 3D layout. Finally, I will talking about the total solution of the wireless and radio frequency systems. Now let's go get introductions. Talking about wireless and radio frequencies, we must knowing about the develop of the communications. In first generation of communication systems, we only can transmission the voice in our systems. And next, the second generation, we can transmission the voice and the text, so we can test someone using our cell phone. In third generation, we not only the voice and the text, we can go on the internet, so we can send some figure to the other ones. The fourth generation, which is popular now, they are not only in the internet and multimedia. So we can solve in the YouTube for every day. But now we want to go to the fifth generation. The fifth generation is a big change of the communication systems. The fifth generation, including the smart environment and IoT or self-driving car, blah blah blah, many applications. Fifth generation is really a big change and a big challenge in the communication industries. The change will including the frequency change and bit data rates and the device update. In frequency change, it goes two-way, the sub-6 GHz and the millimeter wave. In sub-6 GHz, we can continue to use the old equipment of the WiMAX, because the main band of the sub-6 GHz is 3.5 GHz. The cost of building 5G systems is cheaper than the other bands. So the sub-6 GHz has been the main develop of the 5G now. But if we want to develop the 5G communication, we should thinking about the millimeter wave. In millimeter wave, the millimeter wave has wideband characteristic, but accompanied for faster accumulation. This is the millimeter wave physical phenomenon. It means that you can get bit data rate which is larger than sub-6 GHz, but you need to building more base station to transmission the wireless signal. So next, I will introduce the workflow for antenna design. First, we should looking for the frequency band, the structure, and the antenna type. We should decide and make some decision to which type we want to use for our application. Next, we will analyze and design and tune the antenna performance by software. Finally, we can lay out and PCB, do some measurement to our antennas, make some circle with this flow. We can make our product to very well. Sorry. In this flow, we can see the spectrum and the structure and antenna type is the first thing we should focus on. But the simulation, everybody always don't look at that because the simulation result is not the main phenomenon which people care. They always care the measurement results, including the clients want to solve some maybe the antenna gains and the radiation pattern, the S parameter of the antenna, which is measurement results. So many people will do some measurement to their work, and if this work, we can do our job. But in traditional, antenna designer will achieve the design goal by try and error method with measurement. If you have been in this industry, you may have good technique in cut the copper tape. That's a joke. Because everybody will do some measurement to finish our work. However, the traditional method is not working in millimeter wave design. In 5G application of wireless and radio frequency, due to device update, the multi-physical should be considered in the design. So, we introduce to you the powerful software with Ansys. The multi-physics will solving in this software. We can solve the fluid mechanics and structural mechanics, even electronic and magnetics. This is the high frequency analysis by the software. And the system is about the security of the ISO 226. So that's the other view. This is the multi-domain of the multi-physics. Firstly, we should using the HFSS to simulation temperature dependent on material, and using the software to iteration the power loss and density of the thermal source. When using this source, we will put on the thermal software, which is CFD, maybe the fluid and ice bake to analyze the thermal. And we were using the mechanical to simulation the thermal stress. This is simply multi-physics simulations. Now, we want to solve our design and to design some product of the wireless and radio frequencies. We were introducing you Ansys electronics product. The electronics product families, first is the HFSS. which is a full-wave 3D electromagnetic simulation software. And the Maxwell is a low-frequency simulator. The Q3D, which can illustration the RLCG parameters and create a spice model, means IBs from the 3D simulations. The SI wave is the SIPI and the PCB and DC analysis software. The iSpec is the CFD thermal solver of the electronics. The spatial option is the IF and SI circuit. Those options will help the HFSS and the SI wave to solve the SI problem and the IF problem. Next, I will introducing you a shooting bouncing ray. It can solve in the largest structure of the electromagnetic problems. They can simulation the thousands lambda for the structure. And the EMIT is RF interference, looking for RF interference. The software will analyze the RF interference between two systems and even two devices. In SpaceCline, we can fix our 3D model for import to the HFSS. So those three options now is very important for HFSS. But HFSS just only including the SBR, the shooting bouncing ray, and EMIT. The SpaceCline is the other option which we want to pay for the license. Finally, we can talking about the enterprise. The enterprise will including our electronics product for electronics product family for those software. So the enterprise is a new packaging for the solving multifaces. Today we are talking about the HFS, one of the enterprise to solving the electromagnetic problems. If we want to solve the radio frequency problem, we should using the HFSS and RF circuit and shooting bouncing ray and EMIT. We will have some solution in the next, but before that, we should introducing the HFS. In HFS, if we want to introduce the HFS, we should know the electronics desktop, which is proposed from the 2060. The electronics desktop is the platform for the electronics magnetic studio, including the HFS, Q3D, circuit design, iSpec, and Maxwell, simpler in the same platform. So the GUI will become very same with each other software. If you want to learning about Maxwell, you can go through same with the HFSS design, because the model building is using same UI to do this. If you want to simulation with the iSpec, we just you can create the model in the HFS and copy the model to the iSpec, and using the code simulation with two-way simulation in those software to get the even the HFS out the EM loss to the iSpec. The iSpec can using those EM loss to solve the temperature dependent. The temperature distribution. The distribution of the temperature will feedback with the HFS. The HFS will simulation the EM characteristic using this temperature distribution and out the EM loss again to the ice pack. The ice pack will slab in the temperature distribution again and feedback to the HFs. This is an iteration. In my experience, if you go through 3 and more iteration, the result will be convenience. So you don't need to worry about the simulation result is similar with the measurement. If we want to do some multi-physics simulation, we should include in the high-performance computing. The high-performance computing is the faster than the others because it will let your HFSS can using more than 4 core in your device. In HFSS, the default is 4 core in our license. If we want to add more core in our device to simulation with HFSS, we should make a high-performance computing license with that. The high-performance computing license, if we want, we will have one pack about HPC. We can add 8 core within our device to be achieved. So total is 12 code to using for our simulations. So you can use more and more pack if your device have multi-cores. Now we are focused on the HFSS. The HFSS is a 3D full-wave frequency domain electronics field driver. You can simulation anything if that is electronics magnetic field. Maybe we just want to put the connector in our PCB. We can simulation the crosstalk and simulation layer TDR with the PCB. If we want to simulation the user equipment, we call the UE, between the UE and the human body. We call the value is SAR between the 2 devices. We can simulation the SAR. Even the one device is the human body. And also we can simulation all systems of our product, like the car and the notebook. In base stations, we always want to using the HFSS to solve the antenna installed performance of our base station. To do this simulation, we should using the HFSS multi-solver to do some hybrid simulation. The solver we will introduce in the next. Talking about the application of the HFSS, including the antenna, waveguides, filters, and IC packaging, connector, blah blah blah, many things. Maybe LTCC device will include in the HFSS to simulations, and we have the cell phone simulation in our workshop, and we will do some EMI and EMC simulation in this software to solving the EMC problem now. Maybe the EMC problem should include in the chamber to measurement the value between the device and the antenna. The HFSS have some example for the EMC and EMI, so we can see some different parameters of the simulation. Now, the HFSS in the electronics desktop, we can see 3 interfaces. First, there is a 3D interface. the 3D interface, we can using the 3D to model our antenna or the connector. And the 3D interface will including the 3D components, so we can do our library with 3D component. The other interface is 3D layout. The 3D layout is 2D solver in the 3D area. This is very strange, but it's true because the 3D layout will using the method of moment method to solving the PCB problem. The next interface is a linear circuit. The linear circuit will co-simulation with the other interface and to achieve the SI simulation and the IF simulations. If we want to talking about the HFS, the pride of HFS is the meshing technologies. HFS is using the triangle meshing to mesh the many different shape of the structures, like a cylinder and maybe the curve, the curve interface and the curved surface. That's very hard to mention with the rectangular. If using the triangle meshing, you can solve the complex structures. This is the automated meshing technology for the HFSS. If we have some geometry of the antenna, the initial meshing is very rough. In rough meshings, the second iteration we will get some clearly meshing with the meshing technologies, and we will calculate the S parameters of this structure. As a parameter, we will compare the difference with the next station. So we call this value is delta S. The delta S will smaller than the value. We will call this simulation is convenience. Now we will introducing some solver in the HFSS. In HFSS solver, firstly, most and 90% people will heard about the FEM in the HFSS. This is very famous numerical algorithm of the electronics and magnetics. And this is a golden software. Next is the IE, integrating equation. This is the method of moment, MOM algorithm for the electronics and magnetics. And in HFSS IE, we're using the 3D surface meshing to solve in the moment of method. That is the difference between the other software like FICO. And the HFSS have the PO solver is physical optics and the shooting bouncing ray solver. Those solver will solve in the larger problem of the larger structures. And next we have the eigenmode solver and the transient solver. Those solver were using to the time domain and the eigen domain to solve some maybe waveguide and the DDR in the device. In HFSS, if you want to design antenna in HFSS, we can use in the hybrid simulation to solve install performance of our device. And we can easily to synthesize the antenna with the antenna toolkit. Antenna toolkit is very simply to using because you just want to key in your frequencies and design your material of the structure of your substrate. The material is can be seen for the FR4. If you want to do some spatial antenna simulation, like a spiral, maybe the local periodical type of antenna, the structure of the antenna will become complex. So we should using the antenna toolkit to synthesize those antenna in the frequency we want. If you just need to push the synthesis button and push the finish button, you can explore your structure in the HFSS. And the main figure in you, if you want to see some maybe the S11 as the parameter and the radiation patterns and the gain of the antenna. This toolkit will set up the all field of the HFSS. Now, this is the geometry creation of the HFSS. We can use in the spacecraft we have been talking in the form. And we can use in the optometrics do some parameters sweep and optimization of our design. And you can use in the real-time tuning option to tune our antenna device. And finally, you can output the final structure of the antennas. Now I will introducing the new option of the HFS. This option is included in the HFS in 2019. This is the 256 element example. That's A minus A array of the 5G applications. You can saw the structure is very strange because we have to simulation all the device of antennas. You just see some element in the antenna in our model. This is a new technology of the array simulations because this is called the finite array domain decomposition. This is provided in the maybe 7 years ago. In 2019, we using this method to create some new method of the 3D component array. The 3D component array will do the full wave simulation in those structure. We can see the antenna will be cut off with the several elements, maybe the housing, maybe the antenna element, and the circuit of antenna. Next, we will component the array domain decomposition. This is very like a puzzle. We call it, this is like a puzzle to create our array. The HS will copy the mesh result with one element. The copy result will copy to the other similar element. So we can reduce the simulation time with the machine and do the full wave with the total device. You can get the full wave result with the total antenna. And you can using the color, maybe the number and the color to identify the antenna, maybe the part of the element, the part of the power IC, the part of the module, the part of the housing. I think everyone will worry about this simulation is a fake simulation result with the very simply designed city. I will do some experiments about the new method of the array simulations. We can saw the figure in the left. There are two modules of the antenna arrays. Now, in this new method, you just only need 3 elements of the arrays. The other similar part will using the copy to the method to the antenna element. The antenna element the boundary condition will set to the practical boundary condition we call the PBC. Using this method, you will assuming the array is infinite, and using the finite setting to be the array become the finite, and tell the HFSS you need to calculate the EM characteristic in the range of those structures. So let's go get the to result of those settings. The real array is the total model of the array. The 3-component array, we saw the result of each other. Good agreement between those results can be saw in the figure. And also you can output the electromagnetic field, maybe E field, in the simulation. So let's go get the new array. This more than 400 element array of the simulation. Maybe we should spend maybe 1 or 2 days to simulation these results, but we only need to put in the element and the feeding network, which is similar with each others. And we will the HFSS will copy the machine result with the other structures, and we can do in the full wave simulation in those structures. The comparison between 2 results, we can solve the agreement between the 3D component array and the real array results. Now, that above is the HFSS 3D model simulation. Next, we will introduce in the HFSS 3D layout and the circuit. The 3D layout is a PCB. Is using to the PCB simulations, so we can using this interface to simulation maybe the planar array, maybe the planar antenna and the planar device. And the connector will be included in this simulation by the HFSS. So the HFSS and the 3D layout will call simulation if we want to solve some complex problems. Next, we will see the state up the idea and the antenna state up. The HFSS solver will be included in the 3D layout ideas. So you will using the 2D interface to solve in the HFSS solver by HFSS solver. And the 3D layout will be set on the terminal mode because we only get the S parameter in the 3D layout simulations. If we want to simulation the radiation patterns, maybe the far field of the electromagnetic, we should see the I suggest using the HF to solve those problems. Now we want to introduce in the PCB and the antenna in the 3D layout. You can input the EK model from the other CAD software and using the layout GUI to do some layout in the 3D layout. The state up the idea will solve which one is Cooper, which one is FR4. And you can do the same simulation with the HFSS server in this interface. Next, I will introducing the linear circuit simulation. The circuit simulation will using by the power divider design in the HFSS. If we want to achieve our phase array design, you need to design the power divider. So now we can include in a power divider and a phase shifter in our antenna array by the circuit interface. You can using those packages into start the chip package simulation. Let's go get some antenna in package example. This example have the 12 layer of the antenna in package. The structure of the antenna package will be part of the antenna and the feeding network. You can use in the 3D component array or maybe the array option of the HFSS to slab the array and make some radiation pattern synthesis. And you can use in the circuit to simulation the feeding network and using the 3D layout to lay out the feeding network with the array. And if you in the 5G design, you should make the feeding network is very short, straight, and short. The trace will become very short in the feeding network. The antenna will mount into the PCB with the BGA. So this is the simulation result with the antenna in package. Next, let's go to MCAD and 3D components. The MCAD is interface of the input and explore the MCAD. The MCAD is a structured CAD of maybe the SolidWorks and maybe the other CAD will explore the CAD file to the HFSS. The HFSS if you want to input those CAD to HFSS, you can using the MCAD. Maybe the space client can import the MCAD too. So we can using Hyperregion to simulation the MCAD with the antenna. The result of the Hyperregion and the FEM. The FEM will have the short time cost. And now, next is the 3D component library. The 3D component library is a new options and the new interface of the 2020. The 3D component will be including the SMA, maybe some SMD circuit, and the other maybe the Murata of the TDK, or TDK can be a 3D component. The component will be in the library. You can find some component to your vendor, and you can keep the hint of the components. This is a new method if you want to pull the component to our customers. Okay, the time is very goes too fast. I have go through this faster, and now we have see some total solution of the 5G phase arrays. About 5G phase arrays, we can using the method of the HFSS, maybe the united cell, and if you want to simulation array, we should define the united cell in the first, and we can use in the finite array domain decompensation method to slot the array, and using the shooting bunking array to simulation the install performance, and using the EMIT to simulation the link margin of the interference of the coupling in the RF device. And finally, we were using the iSpec to simulation the temperature and the structural problems. Our first is the infinite array. Infinite array, we were using the theoretical boundary condition in the simulations. You can get the array result with the FADDM, the finite array domain decomposition. Next, you can using the length of the circuit to design your power divider of this array. You can using the copper method and link with the antenna device. Finally, you can let your antenna do some beamforming performance of your simulations. And next, you are using the install antenna performance with the U-cell, and using this method, we call the SBR. The SBR is shooting bunking ray. The ray will be put in the antenna. The antenna will become the install performance with the measurement result compensate. We can comparison with the measure result for this install performance. Now, next is the link margin of the EMIT. The link margin is called the base station and the UE, the user equivalent. You can use in EMIT to simulation the coupling of loss RF device. So at first you have to solve many antenna in the building, and the base station will transmission the signal with the wireless systems. If we want to know the link margin of the antenna, we should build in some model of the EMIT. The interface of EMIT is looked at this, and we should build some RF systems for configuration. We can get the link margin of the distance, so we can know our antenna performance if we want propagation for the distance with the 500 millimeter or 500 meter. You should put in the gain, make a more and more gain in the antenna. The final talking about the electrothermal simulation for 5G array. If we want to simulation and the thermal problem in 5G array, we should simulation in HFSS at first. The HFSS will output the EM loss to the iSpec. The iSpec will using EM loss to simulation the temperature distribution of the device. The temperature distribution result will feedback in HFSS. The HFSS will simulation the EM loss again. This is called one iteration. Using this workflow to solve maybe 3 iterations, you can get the real result with this. We can solve the temperature will be come down in some several iterations, and maybe we can add some heatsink, maybe the fans to let the temperature is become very discrete. Next, we will do this is the temperature of the antenna array in 5G. We can saw the temperature is very terrible. So the performance of antenna array is become very, very bad and worse in the two-way coupling. So we can using the thermal software like aspect to simulation the fan with the device. We can saw the temperature is become normal in the we can take off. So the antenna performance will back and the link margin will become normal in this simulation. Okay, I think the time is up. This is my talking about the HFSS introductions. Thanks everybody.